Hello, my name is Daniel Epstein, and I'm presenting the proxy pattern. So here's a funny cartoon, sort of, email by proxy, which is it's showing someone emailing with a puppet on their hand. So it's not actually email by proxy, but it's showing that instead of him actually doing the email through proxy, the proxy is this puppet on his hand typing on the keyboard. And the standard English definition of proxy is a person who's given the power or authority to do something, such as to vote for someone else. So there might be, you might have heard of like proxy voting for stock shares, where you vote for someone that will then vote on issues for a public company. But in software engineering, the proxy pattern is used to provide a surrogate or placeholder object which references an underlying object. So it provides the same interface as the underlying subject class, but there's a level of indirection. So instead of calling the subject class, you call the proxy, and then the proxy calls the subject class. And then it passes these back to the client. So here's some UML of how the proxy works. So you have a client. It's calling this interface, the interface that the actual subject expects, and there's a method on it called doAction. So normally the client would call through that interface to the real subject, and then the subject would return to the client. But in the case of the proxy implements that same interface. So when the client calls it, it's calling the proxy, and then the proxy delegates to the real subject. When the real subject returns, it goes back to the proxy and to the client. And by doing that, you can add a lot of neat little piece of functionality without changing any of the code in the actual real subject. So some usages are for caching. So instead of if you're making a lot of the same database calls over and over again, instead of going to the database each time, if you're always getting an object by the same ID, you can cache it in memory, so that the first time you call it, it goes to the database, and subsequent calls get it from memory, which is much faster. Security and authorization is another use. So you could do a little security check and see if someone's allowed to do that action, or allowed to do the action on a certain entity, and then you can stop someone from actually accessing that data or performing certain actions before it actually hits the real subject. Remote access, so you could have the real subject be somewhere on a totally different server, and the proxy provides some kind of transport through the internet to that remote service. So it seems like it's a local service, but by using a remote proxy, you're allowed to access things without, in your real subject, you don't need to worry about any web remoting or anything like that. You just do your business logic, and the proxy will take care of the remote access. Another usage is using virtual proxy or lazy instantiation. So let's say you have a really complex object with lots of nested things inside of it, and you access, let's say maybe you don't really all the time need to access all that information. Let's say it's a really big object graph, and you only need to get one piece of that information. So you could lazily instantiate all the rest of it. So you wrap it all in proxies, and if they're called, they'll get the actual real data. But if they're not called, you don't get that performance hit. You only get data when you need it. So a lot of object relational mapping uses this kind of technique, where you get this object graph, but it only gets the data from the nested structures when you actually access it, and that uses proxies. Another usage is transaction management. So instead of writing all the code to start a transaction and then roll back if there's an error or commit, that can be handled in a proxy. And then your actual real subject just handles the database calls, the SQL, to get data or put data in the database. Logging and performance monitoring are also something you can do with proxies. So when you call the proxy, it says, can log something and say, here's the start time of this call, and then it'll delegate to the real subject, and then when that returns, you can say, okay, here's the end time, and you can look at the difference between the two and kind of manage all that information to see how many times the calls are being made and how long each call is taking, and that's a great way to look at performance monitoring without actually putting all this code inside your real subject. So here's a code example in Java of caching. So I have a basic interface called retrievable, and one of the methods is get file content. So this is the implementation I did gets file content. So you give it a file name, it goes in the file system, reads through the file, and then returns the string of that file. So it's not going to be very expensive, but just it's going to hit the file system each time you call this. So then I also made a cache proxy which implements the same interface, and right here there's a target. So that's the target class. That is this is proxying, and I also have another structure that's going to contain the data for the cache itself. That's just private to this proxy class. So the constructor, you pass in the target and it sets it internally, so you have a handle, and then the same method in the interface retrievable get file contents. The first thing it does, there's some logging there, but the first thing it does is it checks the cache. If nothing was in the cache, then it'll delegate to the target, and then it'll store that return value in the cache. So the first time you come through here, there's nothing in the cache, so it delegates to the target, goes to the file system, gets the value, puts it in the cache. But subsequent calls, it'll already be in the cache, so you won't have to go to the file system. So if you imagine inside the file system it was like a remote procedural call or a database call or something that's a little more expensive, going straight to memory with a cache is going to be a lot quicker. So here's just my main runner. So it grabs to the actual file service, and this one's the proxied one. So you pass in the target one, and I'm just calling it basically the same thing twice. I'm saying get file contents, and then I'm saying it again. So what it's doing is the first time the cache gets called, that delegates to the file service, and then it returns the value. The second time the cache service gets called, and because it's in the cache, it doesn't need to delegate, and then it returns. So it's an example of caching using proxies. There's also something called dynamic proxies, so you don't have to define them ahead of time. You can create proxies at runtime. So if you have some kind of a lot of aspect-oriented programming frameworks make use of dynamic proxies. So you kind of give it behaviors that you want, like your caching behavior, but dynamic proxies are created so that it seems like you're calling these objects, but they're actually calling these dynamically created proxies, and they're adding in the logic and behaviors that you wanted, the aspects. And this way it doesn't tightly couple the proxy implementation with the underlying object. So you don't have to, when you're writing code in aspect-oriented programming or using dynamic proxies, you don't need to you don't really care about the interface or the target class that you're proxying. You just care about the logic that you're doing. So you say, do this before the call, execute the call to the proxied object, the target object, and then do some logic afterwards and return. So you don't it doesn't tightly couple the proxy with the underlying object. One thing when I was looking up proxies, there was a pattern that was very, very similar called the decorator pattern, and I had a hard time kind of seeing what the difference was between them. A lot of the code examples and in a lot of the forums, people were asking this question, and everyone was giving different answers. So the best I could come up with, they're very similar patterns where there's an interface that delegates to a real object. We got some new functionality. The main difference that I could see was that the proxy hides the implementation from the client. So it's as if the client had no idea whether they were calling a proxy or not. They just make the call as they normally would, and they don't know if they're calling a proxy or the actual object. Where the decorator pattern, the client can be aware that they're calling a decorator and that there's new functionality. And the decorator can even expose that new functionality explicitly to the client. So in conclusion, the proxy pattern is a great way to add functionality to an existing object without exposing those changes to the client. Thank you.